Okay class, welcome back to my channel. So for today's video, we'll talk about the integration formula of inverse trigonometric function. So before I introduce you the formula, let us first define what are inverse trigonometric function. Okay, di ba, say for example, if we have the sine 30 degrees and this is equal to 1/2. Okay, if we get the inverse, or we could say the arcsine of 1/2, this one half here. So the arcsine of that 1/2 is actually equal to 30 degrees. Okay, so as you can see, if you get the inverse, the arcsine of this value, the answer is the argument of the trigonometric function. So the same principle in the say for example integration as the inverse operation of differentiation, or division as the inverse operation of multiplication. Now yung inverse trigonometric naman, that is also the inverse operation of any trigonometric function. That's why we call this the inverse trigonometric function. Yeah, so we apply the same principle here. So that's how we define the inverse trigonometric function. So it's just the inverse of yun nga, yung trigonometric function. Okay, so how did we come up with the integration formula for inverse trigonometric function? Okay, let's take this example. Let me erase this first. Okay, suppose we have a function. Say for example, y is equal to arcsine u over a. Yan. Okay, now, if we want to get the differential of y, we will find the differential of both sides of the equation. So we have here dy. This is also equal to the differential of arcsine u over a. Yan. But the problem here is, suppose lang, we don't know what's the differential of the arcsine u over a. So, you'll be stuck with this, with this equation. So the best thing to do, basta remember lang, what we are trying to find here is the value of the y. Okay? So what we're going to do first is, from this one, from the original given function, we can actually write this as the sine y is equal to u over a. Diba? Applying the principle of the inverse trigonometric function. Yeah, so we can rewrite it as sine y is equal to u over a. Now, same principle, we can differentiate both sides of the equation. We can write as d of the sine y, and this is equal to the d of u over a. Okay, now take note a is constant, but u is not constant. It contains the independent variable. Okay, so what we're going to do here, we'll just get the differential of both sides of the equation. Now, the differential of sine y is actually, ano ba? Cosine y differential of y. And this is equal to 1 over a du. Yan. Now, take note ha, what we are trying to find here is the value of dy. This one. And it's right here. So if we write this function in terms of dy, we can arrive at this equation. We have here dy is equal to 1 over a du all over cosine y. Okay, so you still have y here. So you have to get rid of this y, okay? Or of this cosine y. So how do we do that? Now we will go back to our original given function, and that is y is equal to arcsine u over a. It's right here. Or it could be written as this one. Okay, so we'll use this one. Okay, so you can use that one. From this equation, you could actually apply the principle of trigonometric function. Diba yung right triangle? Okay, so you can actually draw a right triangle here. Yan. And your angle here, the argument of the trigonometric function sine is y. So the angle of the trigonometric function sine is y. It's right here. So your y here, we could put your y here. And since sine, diba, SOHCAHTOA, diba yung sine naman eh, sine theta daw is equal to opposite over hypotenuse. Diba? So yung if this is your angle, your opposite side, if this is your angle, your opposite side is this side, diba? And according to your formula, your sine y is equal to u over a. So your opposite here is u, so you can write here u, and your hypotenuse is a. So you can write here a. Yan. Now, since this is just a right triangle, we can find the length of the side here expressed as a function of a and u. Okay, so applying the Pythagorean theorem, you will find that the side here is equal to a squared minus u squared. Yan. So this is the right triangle. Okay, from this right triangle, you can actually get all the trigonometric function. Say for example, yung sine y is equal to opposite, and that is u, over hypotenuse. Opposite over hypotenuse. That's why your sine y here is u, that's the opposite, over a, that's the hypotenuse. Okay, now our concern here is actually the value of the cosine y. Okay. Now, take note that cosine is equal to the adjacent over hypotenuse, di ba? So, yung cosine daw, yung cosine theta is equal to adjacent over hypotenuse. Yan. So, if you are trying to get the value of cosine y, so your angle here is y. So, if you are trying to get the value of the cosine y, that's actually equal to adjacent. Now, from this triangle, the adjacent side is the square root of a squared minus u squared. So you can put it here, square root of a squared minus u squared all over the hypotenuse. Okay, it's right here. Your hypotenuse is a. So you can write here a. Yeah, so this is the value of cosine y. Now you can substitute this value here. Yan. Because we are trying to get rid of y here, because yung pina-find kasi natin is the value of dy. So you have to get rid of y. So to do that, you just need to substitute the value of cosine y. Okay, so this will be your dy is actually equal to 1 over a du all over your value for cosine y is, it's right here, square root of a squared minus u squared all over a. So I have put it here, a squared minus u squared all over a. Yeah. And you can cancel out. Simplifying this further, your a will cancel out. Then, ang matitira na lang is your du all over the square root of a squared minus u squared. Yan. Okay. So as you can see, your value for dy is actually equal to du over the square root of a squared minus u squared. So nakuha na natin yung value ng du. I mean, yung dy. So nakuha na natin yung value ng dy. So it's right here. So your dy is actually equal to du over the square root of a squared minus u squared. Now you can equate these two equations. This one and this one. Right? You can equate them because since dy is equal to dy, diba? Dy is equal to dy. So you can say therefore that the derivative of arcsine u over a is actually equal to du over the square root of a squared minus u squared. Yan. So this is the formula for the derivative, for the differential of inverse trigonometric function, yung arcsine. Okay, now from this, you can also find the integral of inverse trigonometric function. Now from this formula or from this equation, if you get the integral of both sides of the equation, you'll come up with this equation. So you will have the integral of the differential arcsine u over a. This is equal to the integral of du over the square root of a squared minus u squared. Yan. Yung integral at differential here, it would just cancel out. So you can write this as yung arcsine mo, arcsine u over a is actually equal to the integral of du over the square root of a squared minus u squared. Yan. This is now the formula for the integral of du over the square root of a squared minus u squared. Okay, so I'll just write this one ha. So this will be the integral of du over the square root of a squared minus u squared is equal to the arcsine. Yan. Arcsine u over a. And of course, don't forget the arbitrary constant. Now, this is your formula. So this is the the formula for the integral of du over the square root of a squared minus u squared. Yan. Isang formula pa lang yan. Okay, now how about if we have, let's derive the formula for tangent. How about if we have, say, for example, meron tayong y is equal to arctangent u over a. Yan. Okay. Now, you also want to find for the differential of y. So, you'll differentiate both sides of the equation. So, you'll get this equation. Arctangent u over a. Yan. But you will be stuck here because assuming that you don't know the formula for the arctan u over a. Diba? So, how do we derive the formula for the differential of arctan u over a? So, paano ba? Same lang how. From the original given function, from this one, you can write that as tangent of y is actually equal to u over a. Yan. So this is u over a. Now, this is your working equation. So if you differentiate both sides of the equation, you will get d of tangent y is equal to the differential of u over a. So the differential of tangent y is secant squared y dy, of course. So this is equal to 1 over a differential of u. Yan. So rearranging this function, take note yung hinahanap natin is the value of dy. So we'll rearrange this equation in terms of dy. So this will be dy is equal to 1 over a du all over secant squared y. Yeah, secant squared y. Now, you have to replace the value of secant squared y. So, paano ba yan? Okay, you will go back to the original given function. It's right here, right? Yung y is equal to arctan u over a. Or you could rewrite this as tangent y is equal to u over a. Now, from this function naman, or from this equation, you can draw the right triangle that represent this function. So you can draw it. So we'll have this one. Yan. And of course, your angle. Say for example, your angle is here. This is y. Then tangent, take note that tangent, di ba tangent theta is equal to opposite over adjacent. Yan. So yung u mo dito, this is the opposite side of the angle. So your y is here. The opposite side is u. Opposite daw, di ba? Opposite. So this is the opposite. Over the adjacent. So your adjacent side mo is a. Yan. Now, from this given you can find naman the length of the side of the hypotenuse, this side. Okay, and that is equal to the square root of a squared plus u squared. Yan. Okay? Now, from this right triangle, you can then find the value of secant squared y, or yung secant y lang muna. Now, take note, secant, di ba? So, katuwak, kaw, ko, or yung secant mo, that's equal to, ano ba yun? So, towa, how siya ko. Okay, so second, so it's right here. So your second theta, that's actually equal to the hypotenuse over the adjacent. Second theta is equal to hypotenuse over the adjacent. So this will be your hypotenuse over the adjacent. Yan. So your second y naman, your second y, so you will be using this triangle. This is equal to hypotenuse daw. Oh, this is the square root of a squared plus u squared all over the adjacent, which is a. Yan. So this is the value for second y. Yung pinahanap is second squared y. So you just need to raise this to the power of 2. So your second squared y is actually equal to a squared plus u squared all over a squared. Yeah, this is the value for second squared y. If we will just put it here, the value, we'll substitute the value for second squared y, and we'll get your dy therefore will be equal to 1 over a du all over a squared plus u squared all over a squared. Yan. Then, yung isang a here will cancel out. Ang matitira na lang dyan is 1. I mean, isang a. So, simplifying this further, you'll get dy is equal to a du all over a squared plus u squared. Yan. So, this is now the value for dy. Okay. Now, you can equate this equation, this one, to this equation. Diba? Okay, let me zoom this out. You can equate this equation, this one. You can equate this equation here. Yan. You can equate it. You can equate that to equation. So, you can then say, your dy kasi, this dy is the same with this dy. So, you can equate this one to this one. So, you can say the differential of the arctan u over a is actually equal to the a du all over a squared plus u squared. Yan. Now, to get the formula for the for the integral of arctan u over a, you just need to differentiate both sides of the function. So you can say the integral of the differential of arctangent u over a is actually equal to the differential of edu all over a squared plus u squared. So this will just cancel out. So you will have the arctangent u over a is this is actually equal to the integral of a du all over a squared plus u squared. Yan. Now, let me just rearrange this function. So, you will have the integral of edu all over a squared plus u squared. This is therefore equal to the arctangent u over a. Now, this is constant kasi your a is constant. You can put it outside of the integral. So, this can be written as a integral of du over a squared plus u squared. This is equal to arctangent u over a. Now, after that, you can divide both sides of the equation by a, so to get rid of this constant. So if you divide both sides of the function by a, you'll have the integral of du over a squared plus u squared. This is equal to 1 over a arctangent u over a. Yan. So this is now your formula for the integral of du over a squared plus u squared. Okay? But of course, you should not forget the arbitrary constant c. Now, this is now your formula. Yan. So, dalawa yung formula mo. This one right here and this one. Okay? Let me just put it here for our reference later. Yan. So, this is now our formula. The inverse trigonometric function. Formula of integration. So, yan. We just discussed these two. And we'll have at least 2 sample problems. Okay? Okay, sample problem number 1. I have here, number 1, I have here the integral of dA over the square root of 4 minus 9a squared. Yan. Okay, now, obviously, you cannot use your power formula here because if you do, your n will be equal to negative 1/2, right? And your u will be 4 minus 9a squared. And if you do this, your du will be negative 18a dA. Yan. Your a here, this one, ang a na to, this does not exist in your original given function. It doesn't, you cannot find it here, diba? So you cannot do that. And you cannot also introduce a correction factor because yung a mo is the independent variable. You can only introduce a correction factor if it only involves constant value. Okay? So you cannot use the power formula here. So instead, okay, so yung gagamitin mo is of course yung inverse trigonometric function. Yan. Okay, so what will you do? Okay, now, between these two function, I mean these two equation or these two formula, ito lang naman yung na-involve ng square root, di ba? Square root of a squared minus u squared. A squared minus u squared. And this is also minus. Okay? So, now obviously, you will use this formula, not this one, di ba? Okay, so to do that, so take note how we will use this formula. And for us to be able to use this formula, you have first to identify the value of a and u. Diba? Okay, unahin natin yung a. Your a squared, okay, your a squared is actually equal to, it's right here, it's equal to 4. Therefore, your a is equal to 2. Yan. The next one naman is your u squared. And your u squared here is 9a squared. Yeah, 9a squared. And if you get the value of your u, you'll have 3a. Okay, that's right. 3a. And if you get the value of du, your du will be 3. I mean, your du will be 3dA. Yan. So, may 3dA ka. Okay? So, applying the left side of the formula, it's right here. So, i-apply natin yung left side. This will be equal to the integral of du. Your du is equal to 3dA all over your square root of a squared minus u squared. So, you have here the square root of a squared, and that is 4, minus your u squared, that is 9a squared. Now, obviously, this function is not exactly the same with the original given function because of these 3. Now, since 3 is just constant, it does not involve the independent variable a, so you can introduce the correction factor. And the correction factor is 1/3. Yeah, so this is equal to, you will now then apply the the right side of the formula, of this formula, that is arcsin u over a. Of course, you have to copy first the 1/3 because it's outside of the integral, and you will apply the right side, and that is arcsin u over a. Your u is here, it's already here, that is 3a over the value of a. Your a is 2. So this will be over 2. Yan. And of course, plus c, or the arbitrary constant. Okay, so this is our final answer. Okay, so how do we check our answer? Okay, so the same principle lang how we will, of course, differentiate our answer. And if we arrive at the same function, then that means that our answer is correct. Okay, so we'll just need to differentiate this one. So this is our answer. Let our y be equal to 1/3 arcsine 3a over 2. Yan. Plus c. So we will differentiate. Okay, the-differentiate natin. So we will have dy. This is equal to differential of 1/3 arcsine 3a over 2. Okay, hindi ko na ilalagay yung c because anyway, the differential of c is just 0. So, hindi ko na yung ilalagay dito. Okay, now, assuming that we don't know the formula for arcsine 3a over 2, okay, so what you will do instead, you can rewrite this equation, this one, you can rewrite that equation as, ano ba? Sine, let me use another color. You can write that function as sine 3y. Yan, because you're 1/3 here. If you multiply both sides of the equation by 3, so you will have 3y. 3y is equal to arcsine 3a over 2. Yung arcsine naman, you can put it on the left side. Sine 3y is equal to 3a over 2. Yan. So this is now your working equation. So differentiating both sides of the equation, you will get d of sine 3y. This is equal to d of 3a over 2. Yan. So this will be derivative of differential of sine, that is cosine 3y 3 dy. Yan. And this is equal to 3 halves of dA. 3 halves dA. Now, we're arranging this function or this equation in terms of dy because dy naman talaga yung inahanap natin, di ba? And that is the differential of our answer. Okay, so you will have dy is equal to 3 halves dA all over cosine 3y. Cosine 3y. Meron pa palang 3 dito. So, you have to multiply this by 3 pa. Yan, 3 cosine 3y. Okay. Now, using this function right here, this equation, you can draw a right triangle. So, may right triangle ka. Okay. Now, this angle right here, that's your 3y. And according to this equation, sine 3y daw is equal to 3a over 2. So, sine man siya, this is, yung 3a mo is opposite, and yung 2 mo is the hypotenuse. So, this is 3a, that's the opposite side. This is the opposite side of the angle 3y, and the hypotenuse is 2. So, this will be 2. Now, from this given, you can then solve for the value of this side, diba? And that is equal to the square root of 2 squared minus 3a squared. Or if we simplify this one, this is equal to the square root of 4 minus 9a squared. Yan. So to get the value of cosine 3y, diba? Cosine, that's adjacent over hypotenuse. So your cosine 3y therefore is equal to your adjacent is square root of 4 minus 9a squared. 9a squared all over your hypotenuse is 2. Yan. So you have here the value of cosine 3y. You can substitute it here and you'll get dy is equal to you have here 3 halves dA all over you have here 3 multiplied by the square root of 4 minus 9a squared all over 2. Yan. And yung 3 at 2 mo will cancel out this one and this one. And yung 2, it will also cancel out. So now you have the value for dy. Yung dy mo therefore is equal to dA over the square root of 4 minus 9a squared. Yan. Yan. So this is your value for dy. Yan. Or this is the differential of our answer. That is dA all over the square root of 4 minus 9a squared. Now, as you notice, it's the same with the original given function. So, therefore, we can say that our answer is indeed correct. And that is 1/3 arcsine 3a over 2. So, this one is correct. Now, let's come to the second, sample. So you have your example number 2, and that is equal to the integral of, you have here dA, it's not dA. You have here the integral of d of mu all over mu squared plus 6 mu plus, what's that? 10. Yan. So this is the given. Now, obviously, you cannot use the power formula here, di ba? Because unang-una, your n here would be equal to -1. So you cannot use the power formula. So if you think that you can use the logarithmic formula, that's not also the case, because if you use the logarithmic formula, your u would be equal to mu squared plus 6 mu plus 10, di ba? And if you get the value of the du, you'll get 2 mu, etc., etc. So it contains the independent variable mu. And right here in the original given function, on the numerator, it does not contain the independent variable mu. So you cannot use the logarithmic function. So we will resort to the inverse trigonometric function. So anong inverse trigonometric function man? There are only two formulas that I have introduced to you so far. That is the sine, the arcsine, and the arctangent. So between the two, obviously, yung magagamit mo lang is the arctangent. Because if we go back to the formula given, yung arctangent lang naman ang hindi nag-involve ng square root, 'di ba? Yung arcsine mo, it involves the square root. It involves radical. So, based on the given function, it's right here, this is the given function, the denominator does not contain the radical sign. So, therefore, you can use the tangent, the inverse tangent ng inverse trigonometric function. But before you do that, you have first to manipulate the denominator. So, ano man yung gagawin mo? You can manipulate it like this. This is equal to the integral of d mu all over your mu squared plus 6 mu plus something that will make this quantity perfect square. And that something is actually equal to 9, right? Yan, 9. But based on the original given function, 10 man siya. So, 9 lang yung kailangan mo. Ibig sabihin, may plus 1 pa. And you can group this one. Okay? So, if we do this, the value of this function is still equal to the original given function. So, wala tayong violate na rule in mathematics or law in mathematics. So, you can proceed. Now, this is equal to the integral of d mu all over, if you factor this out, you will get mu plus 3 squared plus 1. Yan. Or I could rewrite this as integral of d mu all over 1 plus mu plus 3 squared. Yan. So, nakaklaruhan na. You can use here the inverse trigonometric function. So first, you have to identify the value of your a squared, and that is equal to 1. So your a is equal to 1 also. And your u squared naman, this is equal to mu plus 3 squared, of course. And your u therefore is equal to mu plus 3. Yan. So you have to get your du pa, and this is equal to d mu. Okay, so swak na swak because the differential of u is the same lang, d mu. It's right here. Okay. So applying the left side of the formula for the inverse trigonometric function, it says there the integral of du, your du is equal to d mu. So we have here d mu all over a squared. Your a squared is 1 plus your u squared. This is mu plus 3 squared. Yan. So you don't need to introduce a correction factor because wala naman, they are exactly the same with the with the previous function. So you can proceed now in applying the right side of the formula. And that is equal to 1 over, okay, let me check that one. That is equal to 1 over, ano daw? It's right here. 1 over A arctangent U over A. Yan. So I can write it here. 1 over A. Take note your A is equal to 1. It's right here. So 1 over 1. Yan. Arctangent of U over A. Your U is mu plus 3 all over 1. Yan. Of course, the arbitrary constant C. Now, simplifying this further, this will be equal to the arctangent of mu plus 3. Yan. And the arbitrary constant. So this is now your final answer. Okay, so this is our final answer. So how do we check our answer? Let us try to check, ha? So to check, you just need to differentiate our answer. Okay, but you cannot directly differentiate that. Equate lang muna natin yan sa y. Your y will be equal to our answer, and that is arctangent mu over 3. Arctangent mu plus 3 pala. Hindi, mu over 3. Mu plus 3 plus c. And so if you differentiate both sides of the function, you will get dy equal to the differential of the arctan mu plus 3. Yan. Hindi ko na susulat yung plus c. So you can rewrite this function, yung original function mo, yung function mo na y is equal to arctan mu plus 3 plus c, you can rewrite that as tangent y is equal to mu plus 3. Hindi ko na isasali yung plus c. Okay? Anyway, because the differential of c naman is just constant. Okay, so if you differentiate both sides of the function, you will get differential of tangent y. Yan. This is equal to the differential of mu plus 3. And so this will be equal to differential of tangent y, that is secant squared y, right? dy. And this is equal to d mu. Since dy naman yung hinahanap natin, so you can rewrite this equation as dy is equal to d mu all over secant squared y. Yan, so you have to get rid of this y, of the secant squared y. So you will now resort to applying the principle of trigonometry or of the trigonometric function. From here, from this equation, tangent y, that is equal to mu plus 3. This is understood mu plus 3 over 1. Understood yan na may over 1 yan. Okay, so if you draw the right triangle, yan, so your angle here is your y. Yung tangent mo, tangent is opposite over adjacent. So yung mu plus 3 mo, that's the opposite side. This is mu plus 3. And of course, the adjacent side here, that is 1. So yung hypotenuse mo, this will be equal to the square root of 1 squared, and that is 1, plus mu plus 3 squared. This is your hypotenuse. Okay? So if you want to get the value of the secant squared y, or yung secant y lang muna, your secant y, that is hypotenuse over adjacent. So your secant y, this is equal to your hypotenuse. This is the square root of 1 plus mu plus 3 squared all over the adjacent side, which is 1. Yan. So, this is the value for secant y. How about the value for secant squared y? So, this will be secant squared y. Therefore, this is equal to, makakancel out yung, yung radical sign, yung square root. So, ang matitira dyan is 1 plus mu plus 3 squared. Yan. This is the value for secant squared y. You can then substitute this value to our working equation. It's right here. And you will arrive at yung dy mo will be equal to du. I mean, that's not du. That's d mu all over. Your secant squared y is 1 plus mu plus 3 squared. Yan. So this is the value this is the differential of our answer. Okay, you can expand this one. You can simplify this further. So you will have the differential of y, therefore will be equal to the differential of mu all over 1 plus, this will be mu squared plus 6 mu plus 9. Yan. Then combine similar term, you will get the differential of y is equal to d mu all over mu squared plus 6 mu plus 10. Yan. So this is now your the result of the differential of your answer. Now, as you can see, this function right here, this equation, is actually equal to this one. So, yan, di ba? Mag-equal sila. So, therefore, you can say that our answer is indeed the correct answer. Okay. So, that's it. That's how we solve. That's how we apply the formula for the inverse trigonometric function, the integration formula of the inverse trigonometric function. Thank you for listening. I hope you learned something. And please don't forget to subscribe and hit the notification bell button below and help me grow this channel. Thank you.